Well, good morning, everyone. We have a number of people that have joined us on the webinar. We want to welcome everybody to the webinar today. We're going to give it just a few more minutes so that those that are maybe running a little bit behind will have a chance to log in before we begin. But we'll be beginning in probably another minute or two. So again, welcome, and we're glad you all are with us. Just for the benefit of those that are joining us, we are recording the webinar today, so we'll have links available after the webinar in case you would like to review the material later on. So we'll make that available to those of you that have joined.
Yeah, and I can share the PowerPoint after. We'll convert this to PDF and send it away.
Great. Well, I think we'll go ahead and get started. It's 4 minutes after the start time, and we want to be respectful of everybody's time. So let's go ahead and get started. I'd like to first of all, once again, welcome everybody to the webinar today. We appreciate your being here with us. Our presenter today is Mahmoud Jaber. Mahmoud is with Johnson Controls. He's been with Johnson for about 3 years now. He's on the Omni team, which is a technical support team from Johnson Controls. Mahmoud holds an electrical engineering degree, a bachelor's in electrical engineering with a focus in controls and computer science from the University of Wisconsin. Mahmoud, thanks for being with us today, and I'll turn the presentation over to you and let you go ahead and begin.
Hey, thanks for having me. Thanks for the introduction. Today, I've been asked to come speak about the cybersecurity landscape in our industry and cybersecurity as it relates to the new ASHRAE addendums called BACnet Secure Connect, which is a set of addendums that ASHRAE laid out for IP devices in our industry as it relates to IP networks and IT networks as we know them today. And so we'll talk about the requirements for more cybersecurity at the commercial buildings BAS level. And we'll talk about the definitions laid out by ASHRAE that define a well-secured commercial building to prevent bad actors from impacting efficiencies and operational downtime of businesses and buildings as we know them today. And so the presentation, if I can go to the next slide here, the presentation today is going to be focused with 3 goals. Like I mentioned, we're going to spend 15-20 minutes in the beginning talking about the importance of securing commercial buildings. I want to talk about the need for BACnet Secure Connect and all the different details behind it. And we'll get into some examples and provide some good definitions for you guys. And then we'll spend the bulk of our time talking about the specific addendums laid out by ASHRAE. These are addendums to the BACnet IP protocol, typically over Ethernet. These set of addendums can be grouped together to be called BACnet Secure Connect, which is a new protocol laid out by ASHRAE, which we'll define and get into the details of. And then the third goal of the presentation is to use the Johnson Controls Facility Explorer product line as an example. Not only as an example to show the different parameters that an engineer would have to consider when setting up an SC network, but also to take some teachings of an SC network that I've created to show you guys some few key details to walk away from after the presentation here today. One thing I asked the group of is please put questions in the chat. This is an ever-growing technology that's very new to our industry. I think cybersecurity as a whole is becoming newer to our industry, and with the ever-growing set of internet-based technologies and the products we offer to our customers, cybersecurity is a bigger need, and BACnet SC might be more common than we all think here in 3, 4, 5 years. So please ask questions if you have them. This is the time to ask, and we'll cover those questions at the very end. I'm also joined by my colleague, Eric Stark, who will facilitate some of those questions as the presentation is going on this next hour. But we'll definitely get to them at the very end as well. And so with that said, I want to start with this picture on the slide to explain the importance of securing commercial buildings for our customers who may be businesses or government entities. And what I have on the slide is a representation of what I believe to be the most underlooked department in any business, which is a business's IT department. And I think we have to start by redefining the importance of IT departments in businesses. I think historically, IT departments have been maybe those first floor office rooms with 2 technical geniuses in them that you go to reset your laptop or get a new charger, or maybe you're locked out of your phone. And I think IT departments have done a fantastic job for us as employees over the last few decades at ensuring that we can do our jobs efficiently every day. Without my IT department, I wouldn't have the laptop in front of me right now. But I think we have to redefine the importance of IT to be a central focus to a business, a central function that brings together different job functions. I'd say that the sole definition and the sole purpose of an IT department is to manage and maintain all the online tools that a business needs to function. If you think of the finance department or the sales department, or maybe you're part of manufacturing or have been in the past, each one of these job departments relies on a set of online tools in order to operate. And if that online tool goes down, that department is impacted. And the secondary downfalls is an impact to the greater business as a whole. And so I'd urge us to redefine the importance of IT to be the manager in maintaining department of all the online tools we depend on to operate every day. And so I think that's a very key importance. So when we go into buildings, when we're working with customers and we're working with their IT departments, and we're finding that these IT people are hard to work with, it's because this is what they have in the back of their minds. What they have in the back of their minds is their responsibility to ensure the operational efficiencies of their business and manage and maintain all the online tools required to run that business. And so that's the importance of IT. And we're going to revisit that idea in future slides. But I think also, and very familiar to everybody on this call, is the importance of securing operational technologies. We'll get into details here, but really simply said, as our industry advances and as we start to apply IP and internet technologies in the products we sell to customers every day, is a greater need for cybersecurity, because the more internet capability we have in our products, the greater gap there is in cybersecurity. There are more avenues of attack now for bad actors to come and impact negatively operational technologies. And here are some examples on the screen. An example I think that's very close to our industry was in 2013, so it's quite a long time ago, when Target's IT network was hacked through a piece of operational technology actually sitting in a Target's HVAC network. And so the importance of securing commercial buildings is twofold. Number one, to protect the IT department's online tools used to run businesses. But number two, to ensure that the operational technologies that we install in buildings every day are operating like they should be. And so that's the twofold reason for securing commercial buildings as we work on them today. And I want to draw a clear distinction to draw a conclusion here on this slide, where on the left-hand side I have IT, and on the right-hand side I have OT. I want to define IT, information technology, as the set of all online tools a business uses to operate. If you're on a sales team and you use salesforce.com every day, your IT department is managing and maintaining salesforce.com for you to use. And you store sensitive company information on that tool. Every company has an ERP system. Johnson Controls has SAP. That's an online tool our IT department manages and maintains. I have a company cell phone. My company cell phone is part of my company's IT network. I'm currently broadcasting this call on my laptop via broadcast software. That broadcast software is downloaded on my laptop, and that is now part of my company's IT department, IT network. I'm also using my company's VPN to do so. So as you can see, I, probably like you guys all on this call, are very locked into your own company's IT networks, and you might not even know it. And it's the responsibility of my IT department to ensure that I can do what I'm doing, make sure that I'm able to do my job every day. And then we can look at operational technology, the OT side of things. If you're an engineer, you're probably working on operational technology every day. If you're a technician, you're installing operational technologies every day. Operational technology can be defined as the set of all electrical, mechanical, and electromechanical components and systems used to run buildings. These businesses where IT departments sit presumably run in buildings. HVAC systems are operational technology. A VAV box is a piece of operational technology. Facility Explorer, the building management system, is an internet-enabled operational technology, part of my operational technology network in a building. Security systems, energy monitoring, elevators and escalators, transferring people across buildings are part of operational technologies. But two examples I have up on the screen that I want to draw an important keynote to are actuators and sensors, edge devices, tier 4 devices. Unlike engines and servers and field controllers, actuators and sensors make up the vast majority of components in a building management system. If we think of the 4 tiers of BAS, there's a ton more sensors in a building than there are engines. There's a ton more actuators than there's a server in a building. And the reason I want to draw that point is because operational technologies historically have been electromechanical systems. Actuators and sensors have historically been electromechanical components used to open and close dampers. Maybe you got a sensor in a duct collecting temperature data, or a CO2 sensor in a space collecting CO2 data. Where historically these operational technologies have been electromechanical, but as our industry advances, and certain manufacturers try to differentiate themselves, these tier 4 devices and all operational technologies as a whole are becoming smarter. They're becoming more internet capable, where historically a company's IT department didn't have to care about an actuator or a sensor. They didn't even know what an actuator did. But now, as our industry is progressing, we're seeing smart actuators. We're seeing smart sensors, where each sensor might have an IP address in 5 or 6 years. These are IP addresses IT departments now have to care about. And so the conclusion I want to draw on the screen is that operational technologies are becoming smarter. And so what we're seeing is an IT-OT convergence, where HVAC equipment, elevators and escalators, actuators and sensors are being brought into the same IT networks that my laptop is sitting on for Johnson Controls. They're becoming more intertwined. And so that's the IT-OT convergence. And it's happening for a reason. Here I have the 4 tiers of building automation as we currently know it, from tier 4 end devices up to a server level. And I think we've historically seen IP enablement at the tier 1 level. Servers have always been IP. We introduced BACnet IP in the late 1900s. I think it really picked up in the early 2000s, where we see BACnet IP at the supervisory and field controller level. But like I mentioned, as we progress as an industry, we have to pay attention to the tier 4 end device level, where maybe you're going to see a smart sensor with an IP address in the future. And this is all to make room for this new technology that we're only now hearing about. All these data analytics technologies that take IP information and run algorithms against it to give our customers better outcomes than they've ever received. Johnson Controls markets its OpenBlue Enterprise Manager. Niagara has the Niagara Cloud Suite. J2 Innovations is another example of an analytics platform sitting in the tier 0, the cloud-based part of our building management system, responsible for analyzing data and giving customers outcomes they've never received before. We talk about energy management. We talk about fault detection diagnostics. These are all the outcomes that we can now provide to our customers by enabling IP in our building management systems. And so it's happening for a reason. And we're going to continue to make it happen as an industry to provide those customers outcomes they've never received before. But I want to leave you guys with this picture on the slide here today. If you were to take anything from this initial conversation about cybersecurity, it's what's on the slide, is that internet capability, though, is a fantastic thing for industry, and OEMs like ourselves are going to continue to push for internet capability in our building management system. It's a double-edged sword. Like I mentioned, with higher internet capability is higher BAS performance, better customer outcomes. But on the double edge, the other side of that sword is higher building vulnerability. Very simply put, the more internet capable your building management system is, the more internet capable your operational technology is, the more vulnerable it is, the more susceptible it is to cyber attacks. The more susceptible it is for a bad actor to make his or her way into that piece of operational technology to disrupt its behavior, but more importantly, to make his or her way to a company's IT network via a piece of operational technology. And you can look this example up after this presentation here today, where there was a casino that was hacked through an internet-connected fish tank thermometer, where historically a fish tank thermometer was a mercury thermometer you put in the fish tank, and whoever wanted to read the temperature simply pulled that mercury thermometer out and read it and put it back in the water. But in this example that you can read about after this call, this fish tank thermometer was internet capable. And so maybe whoever was running the show could read the temperature of the water through a cell phone app. Or even better yet, that fish tank thermometer was connected to a building management system and they could see it in their user interface. That customer outcome was a lot better than a mercury fish tank thermometer. It was a lot better for the customer that way. However, a bad actor made his or her way into that same casino's entire IT network, gaining access to customer information through a piece of operational technology sitting in a fish tank. And so that's a perfect example to describe the double-edged sword of internet capability, where we want internet capability in our industry, and we're going to continue to push for it. But we always have to be concerned about the other edge of the sword. The flip side of the coin is higher building vulnerability. And so that sets up the conversation and the requirement for a more cybersecure BAS, where historically we've had BACnet MSTP, and everybody on the call is probably familiar with it. BACnet IP introduced in the late 1900s, really picking up in the last 6 to 7 years. Some markets adopt it quicker than others, but here is BACnet over Ethernet, IP over this Ethernet cable. It's still BACnet, but it's over a different physical data link, an Ethernet data link. But very simply put, BACnet SC is BACnet IP's big brother. It is BACnet IP with some security addendums mentioned, where ASHRAE says, if you want to do BACnet IP and you want to do it securely, here is how you do it. And so what we'll spend the next 30, 40 minutes looking at is those specific addendums. We'll define how ASHRAE defines secure and commercial buildings, through what they call BACnet Secure Connect. And so the agenda for what we'll talk about moving forward is here on the screen. We'll talk about the specific addendas laid out by ASHRAE. We'll talk about encryption at the data security level. We'll talk about the transport protocol, the application protocol, and BBMDs, BACnet broadcast messaging devices. I know it's only one bullet point here on the screen, but certificates is a massive conversation. We've all ran into certificates before, especially if you've worked in Niagara in the past. You know what a certificate is, so we'll talk about how that applies here to SC. I'll talk about the hub and spoke model. I think ASHRAE defines the hub and spoke model as a topology. It's more of a model because topologies as we know them today won't really change. And then I'll talk about interoperability, backwards compatibility and communication ability between IP networks and MSTP networks, the importance of that and how that works with SC. And then, like I mentioned on a previous slide, I want to talk about the Facility Explorer compatibility with SC to use it as an example to show the different parameters required to set up an SC network, and also to draw some teachings and conclusions from an FX network. And then we'll finish off with future considerations and questions that we as Johnson Controls have as we see our industry put SC to work and really build this out in the next decade or so. On the screen here is a good summary of the differences between BACnet IP as we currently know it and the new BACnet SC as ASHRAE has defined it. The Real Estate Cyber Consortium is a group of real estate cybersecurity experts, and they rank the top 10 vulnerabilities to building security. Number one is really old technology. Maybe you're putting Niagara AX in a building. So really old technology is the number one reason that building will be hacked. Number two is terrible passwords. You put a FX80 on a floor and the username is admin and the password is password. That's the second reason that the Real Estate Cyber Consortium says that building will be hacked. Number three is lack of encryption amongst the building's IT network. And that's interesting because if you look at BACnet IP as we currently deploy it in our industry, encryption doesn't take place whatsoever. BACnet IP does not encrypt data transfer between devices. And that's an interesting conversation because now BACnet SC, I guess the people at ASHRAE heard the news and the first mention of an addendum to BACnet IP is a need for encryption as defined by TLS 1.3. TLS 1.3 is a common security standard that IT people use. It's the most up-to-date version of TLS. And it defines how encryption works and how BACnet SC will use it in our building management systems. So I'll drag your attention to that picture on the bottom of the screen where we can define the importance of encryption and how it works. So if I'm a device, here if you can see the laptop on the left-hand side, sending out information to another device, on the right-hand side you'll see a device that looks like a server. Under BACnet IP, as it currently works, I'm sending information to that server in an unencrypted format. It's called plain text. And so if a user were to hack into that communication chain and try to pick out the information being transferred between devices, it's currently in plain text. It's readable by the human eye. And so it's a lot easier for people to go in there and understand what devices are saying to each other and understand how a network is working. But then comes encryption as defined by TLS 1.3, which uses public and private key infrastructure. Private key is also known as secret keys, where if I'm in a device now sending information on a BACnet SC network, I'll use my public key to convert this readable piece of information to a randomly generated number, either 128 bits or 256 bits. And it's a bunch of random characters put together that is an encrypted format of the data I'm trying to transfer to my other device. And this is important because now If someone were to hack into this communication chain, they're not able to understand the data being transferred. They're not able to understand what devices are telling each other. They're not able to understand how the network is operating. And more importantly, only the device who's intended to receive the information can decrypt the data. Only that server on the right-hand side in this example can use its secret key to convert this randomly generated set of characters to a readable piece of information and use that data as it sees fit. So that's what public and secret key infrastructure allows for us. And I think it solves two problems. One is an obvious solution and the other is a secondary benefit. Number one, it ensures that data is not readable by the human eye across data transfer. But number two, a secondary benefit is now the network can confirm whether or not the end user intended to get information got the information. Because under BACnet IP, there was no confirmation that the intended user got data. It's just a bazooka of information that goes out. And so that's why I bring up the transport protocol. So if we move down to the transport protocol, BACnet IP currently uses IP over UDP. UDP is the user datagram protocol. BACnet SC says you have to use IP over TCP. There's no room for UDP in SC. TCP is the transmission control protocol. I want to drag your attention to the picture on the right-hand side to explain the differences and the key benefits. So if you think UDP attributed to BACnet IP and you think TCP for SC, I know it's kind of flipped in my graphic, but the right-hand side UDP is for BACnet IP. If you look at the different communication methods I have on the bottom of those pictures, UDP enables what's called broadcast communication. 90+% of all data transferred in BACnet IP is via broadcast communication because it's more efficient that way. Broadcast is exactly what you think of when you think of broadcast television or broadcast radio, where regardless of who data was intended to go to, regardless of who requested the data, anybody can have it. Anybody can get the information under broadcast communication, and that's awesome because it's efficient. If I'm a device trying to communicate with another device, I can send my broadcast and just hope the other device gets it. But broadcast communication has a few security concerns. If I'm one device in a set of 20 devices and I want to communicate with one other device, I have no choice but to send my information to all other 18 devices in that network. Is that 18 other communication chains that are interceptable? Is that 18 other communication paths that lead to a building's vulnerability at the cybersecurity level? Probably. Here's 18 devices getting information that don't need information. There's a transfer of data happening that doesn't have to happen. And so that's number one. Number two, I'd say that this can bog down networks. We hear of network storms all the time. And so the working groups at ASHRAE said, let's move away from UDP as BACnet IP currently uses it and implement TCP, the transmission control protocol. This is a one-to-one form of communication enabled by unicast. This is source to end user. And so now I have to be intentional as a device who I want to send information to. If I'm a device trying to communicate with one other device, I have no choice now but to send information to only that single device. And so it's more secure that way. And so to recap some key differences that we've already mentioned, BACnet IP says there's no encryption and communication is via broadcast. BACnet SC says there's no broadcast, it's all one-to-one. And that one-to-one form of data communication is encrypted along the way. And so those are the two key differences here mentioned by ASHRAE. Number three is in the application protocol. The application protocol as defined by BACnet IP is not understood by IT departments. I think BACnet as a whole is a communication protocol that we made for ourselves. But as soon as we introduced BACnet IP in the late 1900s, and as soon as we started implementing IP devices in our networks, we asked ourselves to become IT people. We asked ourselves to start speaking the IT language and speaking to that persona. And so BACnet SC says if you're to make a a browser to server connection, you have to use HTTPS. You can't use HTTP. HTTPS is the more secure version of HTTP, actually secure under the TLS 1.3 standard. S stands for security. And then BACnet SC implements WebSockets. And I'll talk about WebSockets in a future slide. Let me check time here. I'll talk about WebSockets in a future slide, but this is a form of mutual authentication between devices. This is a form of a virtual handshake that we'll talk about in a future slide. And then finally, what I want to talk about is network communication through routers. You may have used BBMDs in the past, BACnet broadcast messaging devices, when you set up your IP networks. BACnet SC does not use broadcast communication at all, and so there's no need for BBMDs upon installation. Take with that information what you will. But that's just another consideration. BACnet SC says every device in an SC network must contain a certificate. And all the certificates in the same network have to be signed by the same certificate authority. A certificate authority is what confirms certificates are well formed and then signs them at the bottom and returns them back to the user and says you can use this operational certificate at each device level. But all devices in network must contain a certificate. If you look at each certificate that a device has, what it really is an encrypted form of that device's information. There are decryption softwares on the internet, they're open source. And if you were to import a device's certificate into one of these decryption softwares, what you'll actually get is a decrypted format of that device's IP information. IP address, MAC address, you'll get all those IT metrics for that device in an encrypted form. That's what a certificate is for each device. And every device has one. I mentioned the digital handshake. Certificates enable a digital handshake between devices, where if I'm a device in an SC network and I want to communicate with another device, I have this form of mutual authentication with this device. And after we confirm that we belong to the same network, we'll do a digital handshake. And now I can send data to and from that device. These certificates are what enable that digital handshake. And then we can look at standard IT practices for certificates. And I'll tell you now, the customers you work with in their IT departments, more likely than not, have used certificates in the past and probably currently use certificates because they have complicated IT networks that they have an obligation to protect. And so you can work with your IT department on certificate expiration periods. These certificates don't last forever. And ASHRAE isn't really clear on how long certificates should be valid for, but industry standard in the IT perspective is renew the certificates every 1 to 3 years. And I guess it makes more sense that the faster you renew certificates, the more secure that network is. Because if I'm a device trying to communicate in this network, and I don't have a certificate that's recognizable by all the devices in that network, I can't communicate in that network. That SC network is secure to only the devices with the same certificate authority signing their certificate. And so like I mentioned, shorter validity periods tend to equate to better security, that bullet point on my screen. I'll also want to make a point on certificate authorities, where ASHRAE doesn't say who can and cannot be the certificate authority, but typically your customer's IT department is probably their own certificate authority. They've probably signed certificates for their own devices in the past. But if you're working with an IT department that's less stringent, maybe you've worked with a third-party certificate authority. You've heard of DigiCert, perhaps. GoDaddy is an open source certificate authority that you could work with. But these third-party sources exist. The picture on the bottom left-hand side of the screen is just a screenshot from one of the addendums laid out by ASHRAE that define what certificates are and the importance of them. But no need to cover that in further detail. So that's certificates, and I'll go on to the next slide here. If you have questions on certificates, please put them in the chat. I will definitely show questions I have about certificates in the last slide of my presentation. Here's the certificate signing process. When you implement your first SC job and moving forward, when you start to implement SC, you'll become very familiar with this process. This is the process I went through when I was testing SC with the Facility Explorer product line. But two entities exist. In the certificate signing process, there's an applicant, and then, like I mentioned, there's a certificate authority, where the applicant is you as the engineer or technician on the job with a set of applications. These sets of applications are the individual certificate signing requests responsible for each individual device. Each device will have a certificate signing request. So you'll go into your certificate management portal and you'll generate what's called CSRs, certificate signing request. Like I mentioned earlier, a CSR is an encrypted form of that device's IP information, very simply put. What you'll do as the applicant is you'll condense these applications probably in a zip file and you'll send it off to the certificate authority. Maybe you're working with the customer's IT department. You give that IT department a zip file that contains a certificate signing request for each individual device in your SC network. That certificate authority will then take these certificates and sign them using their private key. I'll show you an example in the future slide, where really all it is you can take a certificate signing request and put it in a notepad, and then simply add the private key of the certificate authority certificate at the bottom of that certificate signing request. And that's a signed certificate. What the certificate authority will then do is zip those operational certificates in a zip file, send them back over to you as the applicant, and then you'll take those certificates and put them on, attach them to each one of the individual devices in your SC network. And so that's the general certificate signing process that we'll all use moving forward when it comes to implementing SC jobs. And so we have to become very familiar with this process because it'll be commonplace for everybody here. Here's an example of an implementation I did in our Milwaukee office when I was testing Secure Connect. And so as you can see, I've blocked out a lot of the characters in my certificates. I just want to show you an example of how these look to show really there's no smoke and mirrors. So on the left-hand side, I have a certificate signing request. Here's an encrypted form of this individual device's IT information. If you look at the top characters, it begins with MIID. The bottom characters are U equals sign. And then take your attention to the picture on the right-hand side, the operational certificate. The top characters are MIID. The bottom characters are U equals sign. And then the certificate authority certificate, probably its private key, begins with MIID and ends with Vista equals equals. The bottom part of my operational certificate for this individual device is MIID and ends with Vista equals equals. So as you can see, when I have a certificate signing request as a device as an applicant, and I send that device the certificate signing request to a certificate authority, all they will do is literally attach the two certificates together, and that's a signed certificate. And so you look at all the certificates in your network, you can conclude that the bottom portion of all the certificates are equal. It's just the top portion now that's unique. And so that's how certificates look. It really is this simple. Now, if you were to do this with a Johnson Controls product, Facility Explorer or Metasys, those are the two building management systems that support BACnet SC as Johnson Controls has developed. You'll probably run into this screenshot here that I have on the slide. This is our online version of SCT, System Configuration Tool. This is the platform required to configure a network for an engine. The engines you guys are familiar with are the F4 SNCs. If you've worked with Metasys in the past, they've got the SNC and the SNE. It'll be the same dashboard. But this is the online version of SCT. And what this is the certificate management portal. So as you can see, I have a list of all the devices in the network. And on the left-hand side, that column on the left-hand side shows the expiration periods of all their certificates. I have statuses, I have device IDs, I have the model of each device. I have a mode that each device sits in. BACnet SC has devices sitting in 3 different modes at any given time. There's Ethernet IP only mode, there's dual SC and IP mode, and then there is Ethernet SC only mode as the third final device mode. I won't go through the details. I'll urge you to look at our commissioning guide for BACnet SC when we release it. Should be here shortly, to explain the difference between the 3 modes and how that works out when you're commissioning a job. And then the very right-hand side certificate signing request column shows when was the last time I, as the applicant, requested a certificate signing request for that device. And so here's a really cool interactive of certificate management, as it will work with Facility Explorer devices and Metasys devices. Other OEMs will have their own certificate management portals. I really just wanted to show this as an example. But as you can see in the top right-hand portion, import operational certificates, when I've received the certificates from my certificate authority, I simply import that zip file into here, and it will attach the operational certificate that belongs to each device accordingly. So that's a good screenshot to show what certificate management looks like for Facility Explorer using our field controllers. I want to draw the example here using Workbench, because more than likely you're integrating into a Niagara front end. And so on the right-hand side, I have screenshots from Workbench in my SC network. On the left-hand side, I have screenshots from SCT. This is the online version of SCT, just to show you the parameters that match, what that looks like. So as you can see, this SC hub port is network number 3001, as defined in Niagara. In my local SNC's SCT, I have secure port number 3001. Those metrics have to match. I'll also explain the primary hub and failover hub in a future slide, but there are some numbers there that match. In the primary hub, you use the HTTPS port number. In the failover hub, you'll use the network number. So those are, if you were to take a screenshot of anything I've shown here today, I'd pause and take a screenshot of the slide I have here on the screen, because these are the metrics that matter when it comes to implementing a job using SC. We'll pass these slides out afterwards. BACnet SC says that we'll use the hub and spoke topology to define how different devices interact with each other. BACnet SC defines 3 device types. Number 1 is the primary hub. Number 2 is the failover hub. And every other SC device in the network is called a node. Earlier in the presentation, I said that BACnet SC does not use broadcast communication. That wasn't fully true. There's only one device in an SC network that can use broadcast communication, and that's the primary hub. The primary hub is responsible for directing network traffic between the nodes and ensuring that the SC network stands as it currently stands as an SC network. And anytime a new device is added to the SC network, the primary hub is responsible for mutually recognizing that new device with all other devices in the network. So as you can see, it's very important. It also directs network traffic in high network areas. I'm not sure how this works, but the primary hub is responsible for doing that as well. Optionally is a failover hub. Now, I'm going to put an asterisk on this because as ASHRAE defines it, optionally is a failover hub. But as Johnson Controls, we recommend that every SC network has a failover hub. The failover hub is a node that becomes the primary hub if the primary hub were to go down. And the reason I urge every SC network moving forward to include a failover hub is because when we reset devices, when we restart devices, when we upgrade the firmware to devices, they tend to restart themselves. And so if you were to upgrade the firmware to the primary hub and it accidentally restarts itself, you've just lost network integrity to the entire network. There is no primary hub in that millisecond period. And so we recommend a failover hub at any given time. Every other device in an SC network is a node. We currently don't offer any SC nodes, any SC tier 4 devices, but all the IP-SC field controllers we have are nodes. Every other device is a node. And so those are the three different device types. Some questions we have about this slide are about network limitations and device count limits. IP as a whole is very forgiving and allows for a lot of devices to sit on the same network. So we don't have any metrics around maximum device counts. IP is very scalable. But every other device that's not a hub is a node. So all the field controllers are nodes. If there was an SC thermostat, it would be a node. We'll talk about communicating with BACnet IP and BACnet MSTP networks. You'll use routers to do that. Those devices are nodes. Every node and every hub has a certificate, like we mentioned earlier. I finally want to show this slide that brings a lot of the conversation together, which was actually out of ASHRAE's Addendum BJ 135 2016. This was the first publication that ASHRAE put out that mentions BACnet Secure Connect. And the working groups of ASHRAE sat down and said, if we were to move forward with a new protocol, if we were to make addendums to BACnet IP, we have to ensure that these 5 or 6 bullet points remain intact. And the third one that I've highlighted here is interoperability among versions and vendors. So regardless of who made the product, regardless of which physical data link it's using, whether it's MSTP or IP, regardless of which version of BACnet it's using, it better be able to communicate with the network. Because if it doesn't communicate with the network, we're no longer interoperable, and that defeats the purpose of having an open protocol standard in our industry. And so interoperability among versions and vendors is one of the biggest conversations amongst BACnet SC because it's that important. If you focus on the picture here, as you can see, there are a bunch of Johnson Controls field controllers. In the blue circle, I have a BACnet SC network. As you can see, every device in my SC network has a certificate. On the right-hand side, I have a BACnet IP network, kind of daisy chain TCP on the server level. On the left-hand side, I've got BACnet MSTP trunk coming off an engine that is also communicating to the network via BACnet MSTP to SC router. One thing this picture doesn't show is that these routers, the BACnet IP router on the right-hand side and the BACnet MSTP router on the left-hand side, are also presumably secure under the SC standard. They should also have certificates. My picture doesn't explain that. But I want to bring this picture up to tell you guys that interoperability matters because BACnet SC better be able to communicate with BACnet IP and BACnet MSTP, or else our delivery to our customer would not make sense. If you're working on a college campus and a subset of this college campus has been BACnet IP, and you want to start introducing BACnet SC subnetworks in the broader network, you have to be able to communicate with the existing stuff in those buildings. And so that's the point of routers. But I also bring this picture up to say that it's not to say that the BACnet IP and the BACnet MSTP networks you're integrating with are secure under the SC standard, because they're not. This is just to show interoperability, backwards compatibility, and communication ability with the other devices in our buildings. They have to be able to communicate. And so presumably the devices I have in that blue circle are secure under the SC standard, and presumably the devices I have in the IP network and the MSTP network are not secure, but they can still communicate using routers. Johnson Controls offers a full set of field controllers that support the BACnet Secure Connect protocol. As you can see, the CG series general purpose controllers on the left-hand side, I have highlighted in red all the different models that support Secure Connect. I actually have to unhighlight that bottom CGM. All the CGE models, E standing for Ethernet, support BACnet Secure Connect. And then if you look at the VAV box controllers, that F4 CVE is the only VAV box controller we have that supports BACnet Secure Connect. But I also want to say, and this applies not only to us as a manufacturer, but other manufacturers supporting SC, is that it's the same part number. So regardless of if you're doing an IP job or an SC job, you're ordering the same CVE. You're ordering the same CGE. It's just that when you commission the job and you set up an SC network, as we explained in the previous slides, is when you set that device to be SC or in IP mode. And so that's very important, and I'll venture to believe that all the other manufacturers are following the same model, where it's the same IP controller that supports both protocols. So I want to make that part clear. And I think I left enough time for questions. I hope there are some. But this isn't to say that we as Johnson Controls are the subject matter experts and we know everything about the topic, because we don't. We still have questions. Especially when BACnet IP was released in the past, we still had questions about implementation strategies and how we'll interact with other systems and what engineers will think of the new protocol. But these are the questions I have as an engineer. These are the 6 questions I have about BACnet Secure Connect that I think we're only going to find out as our industry progresses and as our industry adopts this protocol at a mass scale. Because these questions are not answerable in ASHRAE addendums, and they're not answerable until we see them happen before our own eyes. But this is where I want to take some time. I don't know if guests can come off mute. Can guests come off mute, Randy? Where someone maybe can come off mute and ask their question. If not, we can go through the chat and answer any that may have come in.
I'm not sure if guests can come off mute or not. If you can and you have a question, please feel free to go ahead and unmute yourself and ask the question at this point. I'm not hearing anybody, so that either means that they can't come off a mute, or you've done such a wonderful job that nobody has any questions at all, and we're all good to go.
Not true. There's got to be some.
I see 3 in the Q&A chat session.
Okay. And really, if there aren't any, I'm sure there will be. The point of doing presentations like this is to not have everybody on the same page in terms of everybody caught up to speed and know how to implement an SC network tomorrow morning. The point of hosting calls like this for you guys as system integrators is to hear it for the first time and know who to go to for questions in the future when you go to implement. And to keep all the considerations in the back of your mind as we see those fit.
Well, with that, it looks like we've had 2 questions. Eric has provided an answer on the chat. Let me just say those out loud so that if you'd like to add anything to the answer, Mahmoud, you have the opportunity to do that. First question is, how often have BACnet IP over IP systems been hacked into since its inception?
Yeah, no, I see that in the chat now. That's a perfect question. I think it's becoming more frequent than it has been, especially as operational technologies as a whole are becoming more internet capable. The building management system and HVAC controls industry is not the only industry to start digitizing. You look at what other manufacturers and other similar industries are doing in what we can call the industrial ecosystem. Everybody is digitizing. Elevators and escalators are becoming internet connected. Power plants are becoming internet connected. EV charging stations, because of how new they are internet connected. Water treatment facilities, power distribution facilities, all these systems that sit part of our industrial ecosystem are becoming more IP connected. And so I like your question because it's specific about BACnet. But I think we can take this question and analyze it at a much broader scale, the industrial ecosystem scale as we know it today. And we can see that these cyber attacks are definitely picking up. I provided a few examples in previous slides. but these cyber attacks are becoming more frequent than they were in the past, certainly. And the more we internetify our industrial systems, the more susceptible we are to these cybersecurity concerns. I hope that answers your question.
Next question is, wouldn't Unicast reintroduce a common IT issue called single point of failure?
Perfect. That's a perfect consideration. And for those that aren't aware of what the question is, I want to go back to, if I can gain access to my slides, I want to go back to the diagram showing the difference between unicast and broadcast. Where in broadcast communication, I am sending information sort of as a bazooka of information, hoping that my end user got the information. But in unicast, it's a one-to-one form. And so there's only really one chance for the end device to receive that data. And so like the question posted, it's a very good consideration. Yes, I would agree that this introduces single point of failure as a consideration, but I guess that's a different conversation. Because the conversation here and the point of BACnet Secure Connect is cybersecurity, not network integrity. They do go hand in hand, but they're two different conversations. And so, yes, to your question, I would agree that in terms of network integrity and getting data transferred to devices, this does introduce the single point of failure consideration. But in terms of security, in terms of securing IP networks and BACnet SC as a whole, it is more secure than using the UDP protocol. So it's a great consideration. It's a good question.
We do have the ability for participants on the webinar to unmute. If there are any of you that would like to take a few minutes, we got about a minute left to unmute and ask another question. Feel free to do so at this time.
A number of the publicly available occasions that indicate a compromising of a system typically comes from external sources on the web because of external vulnerabilities that I'm sure people have heard of the site called Shodan, that where web crawlers find accessible information on systems and post it on that particular site. There's others, but what BACnet SC does is it encrypts all of the BACnet network within the facility from within. So not only does your security provide protection from externally sourced threats, the BACnet SC provides protection from internally sourced threats, so that a potential issue with an open protocol field device through BACnet SC would no longer be a vulnerability, and potential bad player would have no opportunity to interfere with any networks, because if they don't know the cert, they don't get in, and they can't get up the chain. They can't cross over from OT to IT. It hardens the system in a very significant way, that as long as the certs are kept secure, the system's secure.
Thank you, Eric. Yep.
Thank you, Eric. In fact, I'd like to take this opportunity to thank both Mahmoud and Eric for being on the call today and giving us the information here on BACnet Secure Connect. We want to thank everybody for taking your time out to participate today. We hope that you've found it to be helpful, and if you have questions, feel free to leave them on the chat here, and we'll get them answered as well. So with that, we'll close out the webinar for today. Thank you, everyone.